Dear students, I am Dr. Indrani Sarma and I welcome you to the second module of Unit 3. In this module, we will be learning about mechanisms of lubrication. Mechanisms of the lubrication can be classified into three types. The first type is fluid film lubrication. It is also known as hydrodynamic or thick film lubrication. The second type is boundary film lubrication. It is also known as thin film lubrication. And the third type is extreme pressure lubrication. The operating conditions of fluid film lubrication are low load, uniform temperature, and moderate speed. In this type of lubrication, the sliding metal surfaces as shown in figure A or rotating metal surfaces as shown in figure B are completely separated from each other by applying liquid lubricant film between them. The liquid lubricant does not have any chemical affinity to the metal surface and it sticks to it only due to viscosity or stickiness. So it is also known as fluid film lubrication. The pressure developed is sufficient to keep the moving surfaces apart under such conditions as per hydrodynamic theory. So it is also called as hydrodynamic lubrication. The thickness of the fluid film is effective up to 1000 angstrom so that there is no direct contact between the metals. Thus, this is also known as thick film lubrication. The coefficient of friction, that is the force required to cause motion divided by the applied load, for well lubricated surfaces ranges from 0.001 to 0.03 in this type of lubrication. The lubricant chosen should have minimum viscosity under working condition, since the only resistance is due to internal resistance of lubricant. In this type of lubrication, hydrocarbon oils are used. The viscosity of the hydrocarbon oil is independent of the season. Certain additives like antioxidants, viscosity index improvers, organometallic detergents are also used to improve the quality of the oil. This type of lubrication is generally used for delicate instruments and light machines like watches, clocks, guns, sewing machines, and scientific instruments. The second mechanism is boundary film lubrication. This type of lubrication is used when a continuous fluid film cannot be maintained and direct metal-to-metal contact is possible due to certain reasons, such as shaft comes into action from rest, as in case at the starting and stopping positions, or has intermittent decrease in speed, or the speed is very low, or the load is very high, or if the viscosity of the oil is very low, or if working temperature has large variations. In this type of lubrication, it is necessary that a thin layer of oil is adsorbed on rubbing surfaces by physical or chemical or both processes on the metal surfaces, as shown in the figure. This property, which is responsible for maintaining a boundary film of oil by adsorption, is known as oiliness. Oil which has more oiliness than the other oil of the same viscosity gives a lower coefficient of friction at low speeds or high load. The load is carried by the layers of the lubricant which have been adsorbed on the metal surface, forming a thin film of metal soaps which act as lubricant. This kind of lubrication is known as boundary or thin film lubrication. The coefficient of friction under these conditions ranges from 0.05 to 0.015. Vegetable and animal oils have greater oiliness than the mineral oils because of their chemical constitution, mostly their fatty acid content. The boundary film is ineffective at high temperature as the fatty acids break down at high temperature. However, vegetable and animal oils fail at high operating temperature when the lubricating film melts. At the melting point, the long molecules get disoriented and the boundary film breaks down. The oils used in this type of lubrication are animal or vegetable oils and their soaps. This type of lubrication is used in low speed, high load and high pressure conditions, as in axles, bearings, gears, wire ropes, pulleys, tractor rollers and lathes. The third mechanism is extreme pressure lubrication. This is used in case of high speed and extremely high temperature and high pressure and extreme load conditions. The ordinary lubricant fails to stick or get vaporized at the high local temperatures produced at the surfaces. To meet these extreme pressure and high temperature conditions, special additives called extreme pressure additives are added to mineral oils. These additives form a more durable film on the metal surface which is capable of withstanding high temperature and have sufficient shearing strength to withstand the mechanical action of heavy loads. The additives used in extreme pressure lubrication are organic compounds containing certain active groups or radicals such as chlorine as in chlorinated esters, sulfur as in sulfurized oils or phosphorus as in tricrosol phosphate. These react with the metallic surfaces at high temperature to form metallic chlorides, sulfides or phosphides respectively. These surface metallic compounds has low shearing strength and high melting point. Hence, they serve as good lubricants under high pressure and high temperature condition. This type of lubrication is called as extreme pressure lubrication. Extreme pressure additives are used in lubricants as in wire drawing. For instance, titanium can be drawn into wire only in presence of chlorine containing additive which reacts with stable oxide film of metal surface. It is used in cutting fluids, that is the lubricant used in machining of tough metals. These lubricants consist of hydrocarbon oils and small amount of fatty acids and organic sulfide or chloride additives. It is used in hypoid gears, railway track joints and high-speed gears. In this module, we have studied about the three different mechanisms of lubrication. Thank you.